I'm Rachel. I'm currently studying sustainable engineering, chemical and processing at Strathclyde. Before that, I worked in industry for 2 years in food manufacturing. So in sustainable chemical engineering, we're finding there's a bit more of like an ethics component. So we had a module on sustainability where we had seminars actually discussing things such as population growth and things like Extinction Rebellion, which is quite different to what I was used to studying for engineering. So that was a good challenge. And in this semester, we're working on group projects that focus more on what your interests lie within that sustainable, renewable engineering type of thing. Yeah, I think I did. So I found that my undergraduate degree was quite focused on petroleum. Obviously, a lot of chemical engineering students go into petroleum. It's where the money is, and it's where a lot of the jobs are as well. And I found that a lot of the information that we were reading was quite outdated, like books from the 70s that you were sort of then basing your design off of. Whereas what I really like about sustainable engineering is there's so much more innovative stuff that if you're reading papers from like over 5 years ago, it's almost too out of date. And I just didn't get that in my undergraduate. So working in industry, you see a lot of waste and a lot of energy usage. And I think that engineering is going to be really important for solving a lot of the climate crisis through innovations and better processes. So I just thought it would be rewarding to be part of that journey. The group project that I'm working on at the moment, I've really developed my understanding of alternative fuels, of, for example, hydrogen, biogas, and then electrification of boilers and things like that. And it's something that I was aware existed, but just didn't understand how to roll them out. And the group projects allowed me to think of it in like a how easy is it to apply kind of sense. Just because something exists doesn't mean it's very easy to just stick in every single factory around the world for operational reasons as well as money reasons. We're developing a tool that compares hydrogen, electrification and biomass as a replacement fuel for the whisky industry in Scotland. The whisky industry currently accounts for about 1% of Scotland's CO2 emissions, and most of their CO2 emissions come from the heating that's required for distillation. Heating's a big challenge, I'd say, for I think pretty much every industry, because it's not something like with electricity, we've managed to make green electricity very commonplace, but hydrogen, for example, is not particularly efficient. And there's a lot of different ways that you could approach the renewables aspect of it. We first looked at what sectors were hard to decarbonise. So that is things that are using heat generally. So because we were in Scotland, we thought the whisky industry would be easy to access, but we did also consider things like the cement industry and the glass industry because they use such high temperatures. It's very hard to decarbonise them because, for example, things like heat pumps don't get up to those high temperatures. So it's quite difficult to work out. It's quite difficult to just replace the natural gas, for example, in the boilers to find a more sustainable solution. There's quite a lot of distilleries in Scotland, and there's a lot very local to Glasgow as well. So a lot of the people have actually been really quite helpful. They've been able to send us over data or advice, and they've even said that they'd be interested to see our results at the end. So it's quite nice because you feel like you're hopefully giving some people a useful tool to use afterwards as well. So I worked in ice cream manufacturing as a process engineer. Ice cream's quite difficult to make. As you can imagine, it melts. So if there's a problem, then you can end up throwing away a lot of ice cream because you don't plan for there to be huge problems because because it would be a waste of capacity. So obviously there's a lot of energy that goes into freezing things and then keeping them frozen as well. And then you obviously get the waste when you shut down. So even just, you might not think about the pipe work, but if there's a 5-minute stop or a 10-minute stop, which might not seem like long in other manufacturing, food manufacturing industries, but the pipe work's melted. You can't put runny ice cream into a tub, because I don't know if you've ever defrosted a tub and refrozen it. It goes solid because there's air in ice cream. It's like a sponge, and when you melt it, all the air disappears. Yes, I would. I think it's given me a very rounded, like, it's covered a lot of aspects of chemical engineering so at the moment I'm doing a lot on the heating side of things, but we've also covered storage, so modules on electrochemical engineering for working on batteries and things like that, as well as the ethics side of things, and it just gives you the time to research further into things that you're interested in. It gives you the advantage in an interview that you're studying something that you can really get behind in terms of interests and ethics. So then I think it's easier to come across better in an interview, because you just naturally are more enthusiastic about the things that you're talking about.